So to solve this exponential equation, we first need to isolate the exponential quantity. And the exponential quantity is the 3 raised to the 2x minus 3 power. So we need to start out by dividing both sides by 2 so that we can get this exponential quantity by itself. So 3 raised to the 2x minus 3 power is equal to 4. And then as you look at the three methods of solving exponential equations, the first one is to use the uniqueness property where we get the bases on the left and the right to be the same. However, we cannot get a base of a 3 to be a base of a 4 or vice versa. So the uniqueness property doesn't work in this case. So this is where we have two options for solving, what I called method 2 and method 3 in the notes. Method 1 is where you're going to basically rewrite this equation in log form. So method 1 is my personal preference. I find that this is the fastest method. So if the base is a 3, then when you rewrite it in log form, we have log base 3 of 4 is equal to 2x minus 3. Then we're just going to add 3 and divide by 2 to finish solving. So we'll end up with log base 3 of 4 plus 3 is equal to 2x. And then divide both sides by 2. So x is equal to log base 3 of 4 plus 3, all divided by 2. And this would be our exact answer. Then we would go to our calculator to get our approximate answer. And a quick note about how you would enter log base 3 of 4 in your calculator. You would have to remember that the calculator can only do base e or base 10, so we can use our change of base property to change this into a base 10 logarithm. So that would be the log of the argument, which is 4, divided by the log of the base, which is 3. So in your calculator, you could enter it as log of 4 divided by the log of 3. That's how you can enter this logarithm. And then add 3 and divide by 2. And doing so should give us approximately 2.13. So that's method 1, where you rewrite the equation in log form. So for those of you that have seen exponential equations before, a lot of instructors instead choose to teach the method where you're going to take the log of both sides. So that is going to look a little different. If you take the log of both sides, you could choose log base 10 or natural log. It wouldn't make any difference. But you would have the log of 3 raised to the 2x minus 3 power is equal to the log of 4. So this is different than rewriting it in log form. Now you're just taking the log of both sides of the equation. And now we have to use our property of logarithms where the exponent can be pulled out in front and written as multiplication. So that would be the quantity 2x minus 3 times log of 3 is equal to log of 4. Now we have two options. We could distribute the log of 3 into the parenthesis, the binomial. Or since we're solving for x, we could also just divide both sides by the log of 3. So dividing by log of 3 will leave us with 2x minus 3 is equal to the log of 4 divided by the log of 3. And now you can just add 3 and divide by 2. Just continue, or finish, I should say, solving for x. So adding the 3 gives me log of 4 divided by log of 3, and then plus 3. And then finally we would divide by 2. And then I know it looks like a bit of a mess, but that's okay because we're going to let our calculator do all of the number crunching really for us. So that would be log of 4 divided by log of 3 plus 3, and then this entire quantity divided by 2. Maybe parentheses would help clarify that. And then you'd go to your calculator with this as well, but you would still get an answer of 2.13 approximately. And it is interesting to see these methods side by side, because if you take a look at our answers in exact form and decide, well, are they actually the same? They are, because of that change of base property. Method 1, or I should say method 2, excuse me, gave me log base 3 of 4, but over here we have log 4 divided by log 3, so that is your change of base property in action. So that's why we get the same answer, just two slightly different approaches. However, look at the difference in length. The method on the right-hand side is much longer. And I apologize. Let me fix this so that it matches with what I have in your notes. In the notes, I called the first method the uniqueness property your method 1. So this would really be method 2 and method 3. There we go. So part B, still solving this exponential equation, trying to solve it for x. So the first step is going to be to isolate the exponential quantity, which in this example is the 5 raised to the 2x power. So we'll need to add 3 to both sides of the equation. And then we will also divide by the negative 4. So adding 3 will give you, this is equal to negative 4, and then dividing by the negative 4 gives us 5 raised to the 2x power is equal to positive 1. So if you wanted to use the uniqueness property here, you'd be trying to get the base on the left to equal the base on the right. And actually, in this problem, you could do that because you could rewrite 1 as 5 to the 0 power. So we could say, okay, 5 to the 2x is really equal to 5 to the 0 power. And now that my bases are the same on the left and the right, the uniqueness property states that the exponents have to be equal to one another. So that would give me that 2x is equal to 0. And dividing by 2 would also give me that x is equal to 0. So 0 would be my solution to this equation. However, if it didn't come to you to use the uniqueness property here, you could still use the other two methods that I've included. Method 2 would be rewriting this logarithm, or excuse me, this exponential equation in log form. So the base is currently a 5. So rewriting it in log form would give me log base 5 of 1 is equal to 2x. But log base 5 of 1 is really just 0 because 5 to the 0 power gives you 1. And so that still gives us an answer of x equals 0. If you're a person that preferred the other method, what I call method 3, that's where you're going to take the log of both sides. So you would have the log of 5 raised to the 2x power is equal to the log of 1. Then you use your property of exponents to rewrite this with the exponent out in front as multiplication. So that would be 2x log of 5 is equal to the log of 1. And then dividing both sides by 2 log of 5 allows us to get the variable by itself. So I would end up with x is equal to the log of 1 divided by 2 log of 5, which I suppose you could go to your calculator for. But better yet, remembering that the log of 1, well, 10 to what power gives me 1, since it's a base of 10, that's 0. So we have 0 in the numerator, which tells us that this entire quantity is actually equal to 0. So several methods of solving. You pick the one that makes most sense to you.